Hey everyone, agentic workflows are the future of AI. I think that's one we can all agree. But what we can also agree is that the space is very fragmented. What we need in this space is a sense of standardization. Standardization, so everyone's talking about the same language, same protocol, same everything. We're beginning to see the groundwork of a really good standardization come through for agentic workflows. In this video, we're going to be taking a look at all of these standards, why we need these standards, and also at the end of the video, we'll have a multi-agent system that has all these standards built into it in one piece of code. So what precisely are our four standards, or our four horsemen of the agentic workflow that I call it? These are rather fundamental protocols that are paving the way for a truly interoperable and powerful agentic AI ecosystem. That's the future of how AI will interact with people and AI will interact with other AI. These are model context protocol, where agents can interact with other applications or external tools. Agent to agent protocol, where agents are interacting with other agents. LiteLLM, where agents are interacting with multiple large language models. And AGUI, which is nothing but an interaction protocol between an agent and a user. So why do these exist and why is standardization important? If you think about it, main drivers for standardization are to reduce technical overhead. You don't want to be creating something that someone else has created. You want to build upon other people's work. Ethics and trustworthiness. If you have standards, it's easier to set alignments to models for more ethical way of being. Interoperability. You want these different companies to be creating these different agents that can interact with each other in a more standardized way, and to reduce the communication kind of chaos that exists right now. Every company has their own standards, etc. If there is a acceptable standard that is accepted widely, then everybody will kind of start aligning to that. For our demo, we're going to be interacting with multiple agents, and we will be hitting on LiteLLM for model level abstraction, MCP to use some external tools, and a whole lot of A2A. So let's do a quick overview of each of these and break them down and understand them. Let's start with the Model Context Protocol. This is the oldest of these standards. The Model Context Protocol is often described as the USB-C port of AI applications. And think about it this way. If your laptop has a USB-C port, you can connect it to your monitor, you can connect it to an external hard disk, you can even connect it to your charging cable. All that is done through one standardized port. Now, MCP is the same way for AI agents. It's an open protocol that standardizes how applications provide context, and primarily in the form of tools to large language models. Essentially, it's a way for the application to tell what its capabilities are to the agent itself if it wants to use it. Now, it's a little different from APIs because here your application contexts can be tables, data, files, anything and everything, right? Like how do you interact with the application itself? This is huge because LLMs can securely discover and utilize these external data sources and tools without needing custom integrations for each one. Now, what this allows you to do is if there's an MCP way of connecting an agent to a database like a SQL database, you could think about using that same way to connect agent A, agent B, agent C, any agents to that SQL database. You don't have to create a custom set of integrations between each of them. There are wonderful resources for MCP available, and I'm going to link some of my favorites. But all you need to think about is when an agent needs to interact with an application, it's pinging it and it's asking it to list its tools that are available. So once it lists its tools, it's able to call that particular tool and it's able to call that particular tool and use it. Now, what this allows you to do is also build these capabilities in a modular way. So let's say I've added 2 integrations with my database today, and I can go and add a couple more later on without breaking and needing to change anything at the agent level. I can just do it at the MCP server level. Now let's talk about another standard, and this standard is the agent to agent protocol. This is another open standard that was developed by Google, and it has a lot of partners to it. And its core purpose is to standardize how agents interact with other agents. And this is important because a lot of these tasks in the future are going to be agents talking to agents. So you want there to be a common way of how an agent will talk to another agent, meaning how does it know what the other agent is capable of? What are the inputs and outputs of the other agent? What are the skill sets of the other agent, and so on and so forth. The A2A protocol basically does that. And we'll talk about it in our piece of code, like how we define these things. But essentially, A2A builds on existing web standards like HTTP, SSE, and JSON RPC, and puts them in the context of how an agent needs to talk to another agent. The good thing about A2A is it's also capable of handling long running tasks, real time tasks, and even audio video, right? Like, so it's not just text. Now, in this, just like how in MCP, here agents kind of use what's called an agent card to demonstrate or advertise their capabilities, right? Same concept. All of these concepts have a single thread of you need to be able to ping and discover what the other side of the tool set is capable of. Once you actually know that, then you can say, okay, then I'm going to generate my output to come into your input, and so on and so forth. Our next standard we're going to be talking about is LiteLLM. And LiteLLM is like a universal translator for large language models. Basically, LiteLLM is like an open source Python library where it provides a unified API for interacting with any or many of the LLM models that are out there. What this saves you is, let's say you're developing an agent with OpenAI's models to start with, and midway through the project, you're trying to shift to a Gemini models. You don't have to rewrite your code if you use LiteLLM because it provides an abstraction on how you interact with your LLM model. This allows for organizations to set up like a gateway layer so they can kind of interoperably bring in any model that they want. And we never know where these models are going to go in the future. Let's say a lot of these agents may be running in-house with in-house models. So you may want to create that abstraction layer ahead of time for future interoperability. LiteLLM as it stands provides abstraction or supports like about 200 models from all the major players. So you cannot really go wrong by using LiteLLM as your model abstraction layer. Finally, AGUI, which is the Agent User Interaction Protocol. This one is a very nascent kind of a protocol. I wouldn't say this is the one that would be widely adopted, but this is a protocol that is kind of bridging the gap between front end and agents and allowing users to be able to have a mid layer that will allow you to interact with your agents as a user. Now, this is being actively developed, and a lot of frameworks are getting added to integrations right now. We are not going to be looking at this one today because the ADKs, Google's ADK still doesn't support AGUI, but this may be something we add in the future. But I just wanted to bring it out that this layer of standardization is still in its early stages, and there may be additional players coming in. In fact, Google actually has the ADK web piece of it, which you can actually interact with your agents and stuff. And you will see a lot more players coming into this space, and eventually there'll be one that's going to be widely adopted. For now, I think AGUI is in a good space. All we're trying to build is I want to be able to use the CLI and interact with an orchestrator agent. I want to be able to give it some questions around, hey, can you find news, AI news for me, and translate it to, all right. So what are we going to be building? We're going to be building a multi-agent system. Let's look at all the agents that we're going to be building. We're going to have some translation agents, some Spanish translation agent, French translation agent, and then we're going to have an agent that has MCP capabilities that can fetch web search results, right? And then we're going to also have like an orchestrator agent that kind of orchestrates all of this. All of these agents, we're going to encapsulate them into A2A protocols. And I'm going to show you how easy it is for me to interact with an external search service, how easy it is if I use an MCP service. And all of this, again, we're going to implement our LiteLLM, where it applies an abstraction on our Spanish agent. And I can switch different models in the Spanish agent because I'm using my LiteLLM. All right, so all of our concepts are in this code. And we'll take a look at the code, but let's take a look at the flow of what we're trying to do. When, as a user, I interact with the translator agent, I'm using A2A, I'm asking it a question, hey, can you go fetch all the news about AI and translate it to French for me? It goes and uses the MCP service to fetch the news about AI from an external search server, and it fetches it and then brings it back and then sends it to either the French or the Spanish translation agent, translates it, and provides my final result back. So all of this interaction, again, is in the standardized method of setting it up. Now, what are our core technologies in this code base? We're using Google's ADK, which is going to be our framework for agentic workflow. We're going to be using A2A, which is how we set up our agents. We're going to be using MCP on how we interact with an external service. And then we're going to have some large language models, and LiteLLM will be the one that abstracts it for one of these agents. The base layer for all of this in our system, when we're setting this up, we would need Python. And we're using the Python SDK from A2A to do these, making the agents available. Now, let's talk about, before we dive deeper into these ones, let's take a look at what A2A and how are these agents encapsulated in an A2A. I am kind of using the A2A SDK, which just released the Python SDK. So all you have to do is go in there and git clone their Python SDK, and you will have everything that you need to set up an A2A agent. Now let's take a look at what that means. These are our agents that we built as part of our current exercise. I'm going to be pushing them and contributing to the examples on A2A Python SDK. But I'm going to take the search agent and use that as an explainer to understand what is an A2A and how that is set up. All right, so first part's about A2A. The A2A basically is two parts. One is you have an agent part, and the other one is you have an executor part. A2A, as we explained, is a way for an agent to advertise its capabilities. Now, A2A as a framework has different ways that it can function. Remember the things I talked about, HTTP, JSON, RPC, and all that stuff. Now, you want to be able to fit your agent to work in that framework. Now, when you git clone their Python SDK, all of the common files for the A2A will be available to you in the source, right? Everything from server, everything from utils, everything will be available. Now, all you need to do from your side is you will have to just build these agents and build executors for these agents. The reason the executors are important is executors help retrofit the agent to work with the A2A. Now, let's take a simple example of a search agent and go through what I'm talking about. The main things that you have to set up for every agent in this framework is obviously you have to set up a main, which will have the details of that agent. You will have to set up the agent itself, what the agent does, and then you will have to set up the executor. In addition to this, I will give you the Git link for my repo. I've also put in test and CLI client testers. These you can use to test your agent as you build them. Now let's go ahead and look at the main, because this is the first part. The main thing here is understanding how to do an A2A agent. Let's take a look at what that agent card is. Agent card is nothing but an agent that has description of what an agent is, name of the agent, version of the agent, the default input output modes for that agent. You can give it speech, JSON, text, whatever it is. Capabilities of that agent, whether it is having streaming is true or no, and you can have some other capabilities as well. And then the last part is skills. Skills are basically what the agent's skills are for someone to see what the agent is capable of. In our example, search agent, right? So our agent skill is that it can do a Google search. Now it can have multiple skills, but in this situation, we only have an example of a Google search. Now, agent card is what you get when you ping the agent. So when this agent is launched, and I'll talk about what launching of an agent means, you will actually be able to see the agent card. This is the agent card. All right, and we'll do that. We'll test it out. But so we've understood what an agent card means. It basically gives the understanding of what an agent can do, what kind of input it can take, what kind of output it can take. Now, it also gives you the URL that it's going to be accessible at, and so on and so forth. Now, let's take a pause and let's understand the agent definition itself. Agent definition itself, because we're using Google ADK, we're sticking to ADK. We're sticking to ADK syntax. So if you look at this, it's a very clear way on how ADK agents are defined. You have a model name, you have what kind of an agent it is, LLM agent or base agent. You have a name for the agent, description, and instruction. And then in the tools, we're using a built-in tool, right? Like the Google search. So we're using the built-in tool. Now, remember what I told you about you have to figure out how to make this agent run to suit the A2A protocols. That's where your agent executor comes in. Now, for every different kinds of, like LangChain will have an agent executor that's specific to how LangChain agents work. Google's ADK agents have specific agent executor, how Google's ADK agents work. Essentially what you're doing here, if you look at it, and I've kind of commented the code so you can see very clearly what each one does, it basically retrofits the ADK components to fit the A2A parameters. For example, in the agent-to-agent protocol, there's a concept of parts of the output and stuff and so on and so forth. You want to be able to say, hey, this response of this agent is what the parts are. So you'll have to retrofit those ones. How does an agent run, right? Every ADK has a different way of running. LangChain has a different way of running. How do you say this is the way the agent runs, but retrofit it with this is the way A2A run is expected. So this is how it equates to your A2A run. So all of that is what you're defining here. So you're defining what your agent executor class is and how it equates to the specific components of A2A, right? And honestly, the best way to look at this is always use a template. People would have tested this. So build upon that. Take a template that you've built and build upon it. And then you can kind of retrofit the different activities of the A2A to this agent. Now that's what the executor component is. Executor components will mostly be the same for a same kind of agent class. For example, if it's an LLM agent, you can kind of be assured that LLM agents with text and text have the same executor if you build an LLM agent according to Google's ADK versus what I'm building here. You can see that I am converting the A2A parts to GenAI, like A2A components to the Google's ADK, how those kind of relate back and forth. So you can see all of that set up here, right? You can use this as a tool. Now, you have your agent executor, you have your agent, and then you have your agent card. Now, how does this get advertised, or how does this get exposed? And that's where the A2A protocol is. A2A protocol uses some web frameworks to expose your agent. So those are what the Starlet and Unicorn kind of stuff use and expose. So if you look at it here, your agent is exposed as a Starlet application. Starlet is a framework, a light web framework that exposes your agent, and it exposes your agent on a particular port, right? Host and port. And once it's exposed on that host and port, you can then access that agent. Now, let's go ahead and expose this search agent, and let's see how this looks, right? I'm going to be changing my directory to the search agent directory. Okay, so we are going to be running our agent, and that will provide us an agent that is going to be available over here. So we can actually check the agent card by clicking on this, right? Clicking on this, that actually talks about our agent card. So these are our agent cards. So when another agent pings this agent, it will know that this is how this agent is presenting itself. So it will know its input type is text. So I need to be able to provide a text. So let's say its input type is JSON in a particular format. I should be able to provide the JSON in a particular format. Otherwise, I can't go and hit that agent. So this is the kind of stuff that's important for the future of these ecosystem, because you need each agent to be able to know what the other agent is going to be doing and what kind of deterministic expectations are set. Now, let's now that we've set it up, we'll kind of also test this agent, right? And again, this is not related to our multi-agent setup. This is just a single agent that I'm running for a Google search. Let's let's test using the CLI client that's there. Here. And you can see it's expecting a particular way for the it's going and searching. It's giving me these are my most popular Italian restaurants. This is actually true. This is searching from Google and giving me the results. So this way you can actually test out the agent and if the agent is working. And you can actually see that the agent is responding with the details here. So if you look at it here, this is the agent, and this is the agent has received the ADK event, and it's returning all those results, and it's returning your results for you. For us, it's just a text to text, so it's a simple process. Now let's break down how these are set up for our multi-agent system. So this is, again, just a single agent. We looked at how to set it up, how to set up the cards, etc. Let's take a look at how to set up our multi-agent system, right? The concept is the same, but it just varies a little bit different in how it's set up. Now, for our multi-agent system, if you had taken a look at our protocol, at our architecture, this is our architecture. Let's take a look at the process with which our multi-agent system runs. So our multi-agent system runs this way. So from the CLI, I ask what is the latest news in French. It goes to the orchestrator agent and executes the query of latest AI news and target language French. It goes to the search and translate news function, right? So the orchestrator agent has multiple functions: search and translate news and translate functions. So it goes to search and translate function. It goes and calls the A2A agent, which is the Brave MCP agent that we've set up. The Brave MCP agent goes externally to the Brave server, returns the results. And then once it returns the results, it comes back to the translation function. The translation function will then kick it out to the French translation function. And the French translation function will convert this to French, send the text back, which will then come back to our orchestrator agent. Orchestrator agent will then send it back to our CLI. So this is the process in which this will work. Now let's take a look at how we set this up in the first place. Now, these are our main ones that we are touching upon, right? We have our translation orchestrator agent, Spanish translator agent, French translator agent, and the MCP agent. Let's take a look at how MCP is set up, just so you can see what MCP setup needs in a framework like ADK. So popular agent frameworks like ADK, OpenAI, SDK, LangChain, LangGraph, all of these are allowing MCP now. So MCP's implementation is rather easy. When you go to, remember I had like 3-4 different files here, one of which is the agent file itself. MCP agent is all you have to do is add in the tools, you have to just establish MCP toolset, and you have to give the definition of how this Brave stuff is set up. Now, all of this needs API keys, etc. So all of them are in my .envs, but this is all you need to set up and talk to an MCP server. Because MCP is supported in Google's ADK, this is all you need. Now, similar way, even in OpenAI's Agents SDK, it's a very simple use case of just setting up your MCP server. So instead of me building this integration with Brave search service, I just need to give these commands and it's good. It's able to connect to it, it's able to talk to it and stuff. These Brave search service server, MCP server is hosted by Brave. So that's all you have to do. In fact, let me just show you what. So if you look at the Model Context Protocol page for sample servers, you should be able to see some you should be able to see the Brave Search MCP server, which is available in these model context servers. And all you're doing is giving this NPX way of syntax. And that's all you're doing. And everything else is set up automatically. So coming back to our code, this Brave search agent, the agent definition just has this MCP protocol. And everything is handled from there on in internally, right? You don't even need to like set up any more extra stuff other than just giving the API key. Now, coming back to what our agents are, we have our French agent, which is, if you remember, we are setting each of these agents as their own A2A cards, right? So French agent has its own skill. What can it do? It can convert, translate to French, and then it has an agent card. The agent card can say what it's supposed to translate. It can do input, output modes, and what skills it has, right? These are its agent cards. Same thing for the French, the Spanish also. It has an agent card. It has the skills, what it can do. And in addition to it, for the Spanish agent, if you remember, there's a LiteLLM implementation. So let's look at the LiteLLM implementation. So in the LiteLLM implementation, you would, for Google's ADK's LiteLLM protocol, you just import LiteLLM. And since you included LiteLLM, you'd have to just give model is LiteLLM and what model you're using. If I want to switch to a different model, all I need to do is change the model name here. That's it. That allows me to keep everything the same. I don't need to worry about how it's set up and so on and so forth. I do need to give a different tool. And I do need to give a different tool. I do need to give a different key for each model. For Gemini, I need to give a Gemini key. For OpenAI, I have to give an OpenAI key. But you can see that the only thing I'm changing is just the model, right? And you can see that their LiteLLM models are basically defined as OpenAI / for OpenAI models, Gemini / for Google's models, and so on and so forth. So that is the LiteLLM abstraction that you're doing on this agent. Everything else is exactly the same. You're establishing an agent card. You're giving some host. Make sure your ports are different for each of these agents because all of these agents are going to be running at the same time. So you don't want them to run on the same ports. But essentially, you're giving them different ports. You're setting them up. Same concept of what I said for the executor. You're trying to retrofit this ADK into how it needs to work, for which components it needs to work for A2A. You're equating those. Now, you can use the samples that are out there and build from there. But there are some issues. For example, the code interpreter agent that I was trying to build, it is a multi-part way of how it's responding, but A2A still doesn't do a good job of the multi-way. So it's having some issues, which I've raised a bug for. But again, same concept. That's the way you set up your A2As. Now, the main orchestrator agent, which we are doing, the translation orchestrator agent, this is going to have a little different. Because it's using the other agents are going to be tools in that orchestrator agent. So the orchestrator agent is our base orchestrator, which workflows, which kind of knows based on the question, it will send it to the right tool. So if you look at the agent setup for the orchestrator agent, you are giving it a very detailed instruction on what to do, basically, and you're giving it 3 different tools. So it's saying, if you get this, go to this tool, get this, go to this tool. This is a non-deterministic way of doing it because it's an LLM agent. But if you have like a base agent that you are deterministically running for different tools and stuff like that, you can have it there, right? This is just a non-deterministic way of assigning a different tool to a different task. So here, that's the difference, is you're keeping all of these functions here, and then you have to make sure you have your functions defined, and these functions will be defined here. For example, if I have to say, first go to my search MCP server, get the news, and then do translation, that function should be here that gives you that details. So for example, translate to French function just directly goes to the agents, goes and calls the agents that are the Spanish agent and the French agent. But translate to news, get the news and then translate, does multi-step, right? Step 1, step 2. So it does 2 levels, right? So that's the 2 things that it does. That's the 2 things it does. So again, you can modify how these things work, but the goal is you're setting these up in a way that is keeping with the A2A standard. So I've set up all of these. All right, so let's start spinning these agents up. So let's start with our Spanish agent. This is going to spin up our Spanish agent. Again, we can kind of ping you can test this agent card by pinging the agent with /well-known agent.json. You can see what it does. Same things that we saw. These are the agent cards. Now let's go spin up our French translation agent. Same thing, it's on 1.1. Let's take a look at 1.1, French translation agent. And then let's go ahead and spin up our Brave MCP search agent. (1009). Okay, so now all of these are running. Let's also spin up our translation orchestrator agent. Okay, so now all of these are running. Let's take a look at this one. Just making sure. Just to 0. Okay, so this is the one to this. And basically these are the things. Now let's ask a question, right? So when I ask a question that is running to the orchestrator agent, I'm going to ask it, what is the latest AI news in French? It needs to hit my other agents and then respond, right? So this is my question, and this will be needing to be answered. And that in turn first goes to the translation agent. You can see that it's running there. It's grabbing the news. That needed to have gone to my Brave agent, which got the news from. Then it went to my French agent, which it converted. And finally, it's back into my final thing. So it's giving me all the AI news in French. So basically what you've done here is, let's assume this is just a nutshell, right? This is multi-agent, but in a nutshell. Think about this multi-agent, but in a large scale, right? You're having another agent that's specialized in certain things. So if it's specialized in certain things, you are essentially sending details to that agent, and you don't know what that agent, the specialized agent, requires from input, output, and stuff like that. So you are basically asking the agent, hey, how do you want your input, output? It gives you input, output. What are your skills? This is your skill. So you're able to kind of have these agents interact with these agents. Think about dynamic running of these things that I just did. So assume that it didn't even know these Spanish agents and stuff, agents existed, right? Let's say it is pinging it at that moment to that endpoint and asking what it can do, and then getting the details and then sending it back and forth. So what this allows you to do is to build these independently and provide these agents and a way to like communicate with each other. Now I did all my agents in ADK. I could have totally done my agent in LangGraph, so I can have my LangGraph agent be interacting with my ADK agent. That's where the real interoperability comes in, right? So that's an example of how you can do these. So in this way, we can build very complex systems and build them in a way that each system can independently talk to each other, and there's a sense of standardization for each of these systems. This is going to be how the future of agent deployment is going to look like in production systems. And for our next videos coming up, I'm going to be showing how we can deploy these in production. We can use Google's agent engine to deploy these. And we're also going to be talking through how we can use different agents from different frameworks talk to each other using A2A.